Okay. Little chat?
No.
Hmm?
He's sick?
No. Okay. All right, back to aluminum. Guys, looking, so we finished. This should go fast. So I have aluminum there. Now I'm gonna write down literally everything my finger touches. So I always start with hydrogen and I hit a 1s. So I'm gonna write a 1s.
And then
Guys in the back, why are you not writing?
2 is.
You two, you three. Where are your notes?
Right here.
Get on the right page, write it down. We're turning in notes soon. You need these grades. Okay, so I track my finger, and this is 1s, and I wrote it down. Then I start back at the next row and write down my finger touches, so I write a 2s down.
1s.
So it goes 1s and 2s. I go across and I still have not hit aluminum yet, so I'm gonna keep going. So I go across and I hit here, which is 2p.
I agree.
So I write 2p. I go all the way through 2p, and I still haven't found aluminum.
3S.
So I gotta go back down to 3s. It's always all the way across and back over. Now I write a 3s.
We go to 3P.
You do. Go all the way across, hit a 3p. Now this is where I will stop, because this is the row or the section that aluminum is on. So now all I have to do is, instead of putting those arrows, those boxes, this is actually easier. I'm gonna literally count for my 1s, how many boxes did I touch? 1, 2. And I'm gonna put a 2 up in, like, what do you call that? When it's up high. It's not a subscript.
It's
Is
the
this
second
connotation?
power. It's a power.
Yeah, raising it to a power, but there's a better word for it. It's gone. But the 2 goes up high. Now I go across and write it. Now
Little two.
the 2s, the 2s also has 2.
It is called.
Because S's always have 2. So you could just be keeping track of the fact that S's always have 2, and then they got 2 arrows. Well, you also write a 2.
P's have 3.
The P's, no. How many do P's have? 1, 2, 3, 4, 5, 6.
7.
They have 6 boxes that got all the way filled.
2, 2, 6.
And then I went back to an S. 1, 2. 2 again. Now here's where the dilemma happens. Just like when we were doing the boxes last week, I only want to go as far as my element did. So aluminum's in the first box. So it's just 1, and you're done.
I know, mate.
Okay, so we're gonna do the same thing in our other practices. So it's the same process, and just instead of drawing the boxes, which takes more time, we gotta just write little numbers above them. All right, let's find 10. So 10 is SN. It is way down here, so this one's gonna be longer. But here's the trick. If they are longer than your original one, you always start with the lower energy levels first. So technically, all of this stuff is gonna be the same. I'm just gonna go past it. So I'm just gonna copy it down. I know I'm gonna start with a 1s2, a 2s2, a 2p6, a 3s2, and then when I got to the 3p,
Oh, calm down.
this
there,
time I'm
Steve.
actually gonna go all the way through it because I didn't get to 10 yet, so it'd be 6. That's just a kind of way to cut down your work. If you start realizing that the lower energy levels are always filled at first, that is literally always the order you track your finger on that periodic
How do
table.
you do that so fast?
Well, I've done it for a lot of years.
3P6? It's the same thing.
Yes, I have not finished. I'm just saying that that's where I'm gonna start. Now, once I've passed 3P, now I'm gonna keep going until I get to 10. I just knew it was all gonna be the same to that point because I always go in the same order. So now I'm past 3P and I'm here, drop down, and I go 4S. All right, so I'm gonna add a 4S.
Now we need that D stuff.
And now I finally hit the D block. So that is a 3D. And I go all the way through the D block, and I hit the 4P. Now I'm kind of out of room on my board, so I'm gonna write 4P down here. And I'm gonna go all the way through 4P, and I still haven't hit 10, so this is long. Okay, so when I drop down, I hit the 5S. Go all the way through the 5S and hit the 4D. Go all the way through the 4D and hit the 5P. And this is where I will stop because this is the one where 10 is at.
Oh, dang the faucet.
Now I just gotta fill in the right numbers.
4P, you said? 5S.
5P. Track your finger, yeah, and track it.
That takes, I'm just gonna have to go.
Now, for S's, they always get 2s. That should just be something you're starting to get in your head. S's are a sphere, they only hold 2 electrons, they only have 1 orientation. And then D's, well, D has 10 columns. It holds 10. So it's always 10 if it was filled. P's always hold 6 because they have 6 columns. 1, 2, 3, 4, 5, 6. Then S's on back to only 2 again. D's on back to have 10 columns.
P's are worth what, you said?
Count them. 1, 2, 3, 4, 5, 6. And then, oh wait, it's not 6 there.
There's 2.
There we go. So on our last one is always where you have to stop and think, okay, where's my element? 10 is at 1, 2, 5p. So it only went 2 in. So there we go. All right, we're gonna practice one more, and then I actually have an even easier one to show you.
D blocks worth 10?
I'll count them. 1, 2, 3,
Okay, I was just making sure I was right.
7, 8, 9, 10.
I was making sure I was right.
I have to-
Radium.
We're about to do radium. And then I'm going to show you even a faster method. So this one is faster than the one we learned last week. And there's even a shorter notation.
Wait, I'm confused on P block. It's worth 1 or
Okay.
6?
6.
Because there's a little box up top too.
All right, we got this. I'm going to erase it so I have more room for radium. Okay. All right, so radium is really far down. So I'm going to go ahead and start copying what I had up there. 1s, 2s, 2p, 3s, 3p. I'm going to fill in the numbers because if they're filled, it's the same.
Party,
And then I'm going to keep going. So radium is way down here. Where is it at? Trying to find it. There he is. The radium's way down there.
Are you assuming it's gender?
I generally make things easy. I don't know why.
I'm just doing
All right, so I'm going to keep going. So I'm past the 3p. Let's erase up here so I can see tracking it
We
again.
have this one on our notes or no?
Oh, the radium not on your notes?
No.
Well,
Where's
let's see.
radium?
We already did radium.
Radium's on here, doesn't it?
Why are you confusing me?
We just did radium.
We did not, we did
We did
10.
not.
Up there,
Gotta fix it.
just had it on there.
That was 10.
I'm gonna freaking cry.
You're blonde.
Okay, starting over. You're confusing me. 3p6, and we got the 4s. I'm just going to go ahead and start writing 2, because if I have to track my finger, 4s, 1, 2. Then I hit 3d. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just reminding you. And then I hit 4p. And I go all the way through 4p, and p's always have 6. Now I'm going to keep going. And I get to 5s. 5s's have 2. Then I get to 4d. 4d has 10. Then I get to 5p. 5p has 6 all the way through it. Keep them going. 6s. 6s2. Then I hit 5d. Now here is where the little tricky thing happened. Okay? Now this is probably where you messed up. This is the only reason we have radium is to show you when this weird thing happens. This is when we hit the F block. Only time. So if I'm here, do you see how on your periodic table it has this weird thing? And it tells you it goes there? You see it?
Oh, yeah.
So this 6s2 is actually going to drop down and go to my 4f. It's weird. I know it. Follow the arrows. It's never going to matter until you get down to this 6s, 7s. But on the 6, it's actually not going to hit 5b first. It's going to drop down and go to the 4f. Follow the table.
That is weird.
After you follow the table to 4f, then you'll go back and finish where you left off, which is 5d. And I'll go all the way through the,
Would it be 4F14?
yes. So if I'm counting my 14, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there's 14. So F's are always a 14.
We know our number.
You're not going to get to F's very often, mostly because I don't like making you have to write them this long. I'm just showing you that this is how I do it. You'll probably have one example in your homework that goes this long.
Homework.
Well, your assignment for today. Then your 5D is always 10, because D is 10. Then I hit 6P, so I made it all the way through the P's. And now I'm to a 7S, and finally, we are at where radium is at, and 7S is on a 1, 2. So it's actually a filled S shell, 7s2. And there's radon. Okay. Woo, that was long. Now, because those are so long, I think we could agree that that's not fun to write. So they have made shorter versions to use when we have those long ones. Now, I wouldn't use them for like the top elements, boron, carbon, nitrogen. Like I could use the regular electron configuration for those. But when I'm getting down to radium, that is a lot to have to write down. So there is a shorter method. And that is this, the abbreviated configuration. So we're going to practice some of those. Okay, so just so we can keep the periodic table in view, I'm going to erase this and put the first abbreviated element just so we can keep the periodic table in view. What's the first one? Strontium? Okay, so I'm going to replace this with strontium. Don't do this in your notes. Write it in its right spot. I just want to keep my periodic table in the same screen so I don't have to go up and down.
Yeah,
Wait a
it
minute,
says,
wait a minute,
shows this
Yeah, there's a little
structure of
bit.
the electron in the atom
Before the security.
Okay, Lindsay, she has it in third time.
And I'll fill in the blank.
Never. Lindsay, you would never hit me.
So abbreviated configuration shows the structure of electrons in an atom by substituting a portion of the electron configuration with a noble gas. Okay, so you're going to have to know where your noble gases are to be able to do this shorthand. They are the last column. So the very last column on the periodic table, helium, neon, argon, krypton, those are noble gases.
Noble gas and brackets examples.
Yep, here we go. So examples, I'm going to pull it back up where I was
Ornate.
so we can see the periodic table in the same spot. All right, so what it means by putting a noble gas in brackets is I'm going to find strontium, which is right here. Now, strontium is pretty far down the table. If I wrote out its configuration, it would take me a while, lots of things to write down. So to shorten this, you're always going to go to the noble gas that's before it. So basically, I go down the row. This is the noble gas after it. I want the noble gas before it. So I'm just going to hop up. And I'm going to start my electron configuration with krypton in brackets. So that's what I just said, a noble gas in brackets. I'm going to write krypton, which is noble gas. I'm going to write its symbol in brackets. And then all I have to do to finish this electron configuration is write the rest of it that is past krypton. Okay? I'm going to scroll this. If we start at krypton and I need to get to strontium, I just finish it. So I'm going to start here, go back to the beginning. I hit 5s, and strontium is 1, 2. Bam, done.
Strontium
As
is
you can see,
45.
that was a lot less to write than 1s2, 2s2, 3p, 3s2, 3. Yeah, it's super easy. That's the abbreviated electron configuration.
KR.
Nicer to write. What?
KR is the abbreviation.
Yes, KR is krypton.
And last question, 5, is that like a smaller 5 or is it the same thing?
This is a 5s.
Oh,
Okay, now I'm gonna do the next one. So what's the other?
thanks for your help.
Iodine. All right. So I'm just gonna erase this and write iodine again, just to keep my periodic table in view. Iodine. All right, so we're gonna find iodine. It is
53.
right there. So again, we're gonna go to the noble gas that precedes it, is before it. In this case, it's actually still krypton. Okay, so we go to the end and go up. Krypton is still the noble gas that is before it. So it's still the one we write in brackets. But what's different is now when I finish this one, I'm gonna have to go further. So I'm gonna take my krypton, I'm gonna make that my new starting point,
I agree.
and I'm going to go to iodine. So if I start here, I hit 5s, and as always get 2.
What's iodine? I've heard that before.
Iodine is like, it's a brown liquid you can use
Yeah.
to clean boo-boos.
It looks nasty though. It's
It
like-
does. It also stains. So I went through that, and then I hit 4D. 4D always has 10. Then I hit 5p, which is where iodine is at, and this is where I count to where iodine is at. 1, 2, 3, 4, 5. And that's how many it gets. All right, we got one more example to write down. What is it? Tantalum. Okay. Tantalum, which is Ta. So our last one is going to be Ta tantalum. It's a weird one. There we go. Tantalum.
Would that be X?
Yes, so we're going to go to the end and go up. So the noble gases before tantalum is xenon, which is Xe. So I'll put Xe in brackets, which is xenon, because that is a noble gas that is before tantalum.
Tantalum.
Now, when I finish with, I'm going to make xenon my new starting point.
We already did iodine?
Yep.
Oh, I was doing one before.
Okay, we're starting with, just go to tantalum.
Okay.
So xenon's my new starting point. I'm going to get to here. So I hit 6s. Now remember, this is weird. Anytime I hit a 6s, I'm actually going to drop down. It drops me down to the F block. So I have 4F, 14, because there's 14 rows or 14 columns in the F block. And then I get a hop back up. So I go all the way through it, get a hop back up and finish. So I have 5B and count over how many tantalum is. 3. It's 3 over. All right. So that's all your abbreviated. Now the last part is just answering some quick questions based on their endings. So if you have noticed, most of the beginnings of electron configurations for elements are the exact same. We always start with 1s, and then 2s, and then 2p, and then 3s, and then 3p. They always go in that order. So the beginning is always the same. The ending is what is different. Okay? So if I scroll down, you should be able to tell me what element something is just by looking at the ending. So you go look for 3d5 on your periodic table. If I scroll up, here's 3d. 1, 2, 3, 4, 5. It's manganese.
Like, do you just write that out?
You can put N in, that's fine. So I scroll back down. So the answer is N. That's how I found it. So then I'm going to go look for 4p3. Move out of the way, line.
Wait, 3D5 is NM.
Because look, I have 4p, and I'm looking for 4p3. 1, 2, 3.
How are we figuring out from the numbers given? Like the 3D5. So we go to the 3, we go to 3 on the D block, and what's the 5?
You count. What was 4p3? What did I just say?
AS.
So we go to the D block and count 5
What?
over.
AS.
AS, arsenal. Okay. So you go to the block, 5F. And then we're going to count over 10. Here's 5F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Well, that's not how bad.
So that's E. Can't even see my ES.
Yeah.
Wait, but how do we know which part of it is? Like, there's the E block and there's 2 sections to those. We start on the top row.
We go to 2S.
I understand how to, you know what I'm saying?
And then the first one is 1.
And just plug that here and say, what is the other number? When we start on the top of the one.
This is 4.
4.
So this is 4F, this is 5F.
Oh, okay, sorry.
If you didn't label it, label it. The first one's 4F, the second one's 5F. All right, so that was in the notes. You should be able to do your worksheet now. As you can see, like, it's not that hard. So I did expect you to get done with it. But if you need help, including people on virtual, you can ask me questions. But that was the end of notes. I am going to stop recording, and then I'll join the meet again. Actually, I think I just hit stop. There we go.